Today we're talking about marine sediment sources and compositions. Next, we'll talk about zonations. This is looking mainly on where does sediment come from, what is it made out of. This map, which I love, is showing the thickness of sediment on the basaltic continental crust all over the world. With dark blue, meaning there's very little sediment, maybe even bare rock, there's no sediment on top, and then all the way up to that deep red being tens of kilometers thick, right up to 20 kilometers thick. Um, so I want you to just spend some time with this map and think about what patterns do you notice of sediment on the seafloor. I want you to pause the video here, scroll down to the very first question. It's going to ask you to list three different observations, and I want you to be specific in your observations. So, for example, don't just say there's different amounts of sediment, different places, right? Which places have the most? Um, is there some sort of latitudinal difference, longitudinal difference, different types of coastlines having different amounts, right? Be very specific in your answers. But pause me for a while, spend some time with this map, answer that question, then continue on. So sediment, how big is it? We're going to talk a lot about sediment grain size, the diameter of each individual grain of sand, silt, or clay. And I know on the surface it might seem boring and why do we care about tiny little changes in the microns of sediment? But the grain size of sediment is so important to how that sediment moves and is transported and where it deposits and what type of ecosystem it makes. So, just a few millimeters can totally change an ecosystem. So it's important to be able to talk about how big the sediment is. When we talk about it, we talk about the diameter of a particle and we use the terms sand, silt, and clay. And each of those words refer to a specific grain size range. So for example, sand is any particle that ranges from 0.05 millimeters to 2 millimeters in diameter. That means that when you rub it in your hands, it feels gritty. It feels like if you rubbed it on like soft skin, you'd eventually rub yourself raw. That's sand. Silt is a little smaller than that. So when you rub it in your fingers, it still feels gritty, but it doesn't necessarily hurt. Like you can feel individual grains if you really concentrate. But it doesn't feel like you're going to rub your skin raw. And then clay, those grains are so small that when you rub them in your fingers, you can't even feel individual grains. You can put it in your mouth, and even your tongue and your lips, which are highly sensitive, can't feel those individual grains. Also, those grains become platy, meaning they're thin and flat rather than round like silt or clay. Um, I really, really like this figure because it shows what different grain sizes look like. We're going to focus on sand, silt, and clay. You can break up sand into fine sand, medium sand, coarse sand. You can also go up to gravels, which contain granules and pebbles and so on and so on. We're focusing on sand, silt, and clay. Um, and know that like sand you can see, silt you can see if you squint, clay you cannot see with your eye, right? It's too small to see. You can see it, you can see clay if there's a ton of particles all together, but an individual clay particle you're not going to be able to see. Right? And I said the difference in grain size changes how these sediment grains are transported and deposited. Sand is going to sink really quickly, right? You put it in water, whoop, it goes to the bottom within a matter of seconds. Silt can take a while. Clay sinks so slowly that in, for all intents and purposes, it doesn't sink, right? It stays in the water unless something brings it out of the water column. That's why our water off our coast is pretty murky and cloudy. It's because there's a lot of mud in it, a lot of silt and clay. We combine silt and clay into the term mud. And this creates zonation on our coasts. So near our coastline, like when you go to the beach, you're going to get a lot of sand. That's going to be terrigenous sand, meaning the sand that came from the land. If you go a little farther out off to the continental shelf, that is where anything that is large enough to be called sand has already settled out. It's already, right, taken seconds to minutes to sink out of the water column. So what you have there is the smaller stuff, which is silt. So if you go off to a continental shelf and you dive down, you go scuba diving, the sand or the sediment there is very, very soft, very, very fluffy, really easy to pick back up because it's made out of more silts than sands. You go even further into the abyssal plain, and that's where you get silts and clays, right? Again, clays are so small that they don't settle in water um, on any sort of reasonable time scale. They can do it over, days to years. And that's what eventually settles in the really calm abyssal plain, because any sort of wave movement, that clay is being picked back up. And the calm, silent, still abyssal plain, you'll eventually get clay deposited, or what we call silt and clay, mud together deposited. And it's going to totally change the ecosystem, right? It's so soft out there. It's really easy for organisms to burrow. It's also made up of something totally different, right? Different nutrients, different pollutants and stuff like that become absorbed to it. So in class, we are going to complete activity 4. So don't worry about that yet. We'll do that as a group in class. This is when you're actually going to be able to like feel the sediment for yourself and get a good idea of the different grain sizes, what they feel like. But I do want you to remember what 2 grain size classes together are combined to form the term mud.